Welcome to Lesson 2.3, Apply Deductive Reasoning. So we've already looked at inductive reasoning, which is based on patterns or a specific example, and then drawing a conclusion or coming up with a rule for the pattern. Now we are looking at deductive reasoning. And deductive reasoning uses facts, definitions, accepted properties, and the laws of logic to form a logical argument. So now the goal for today's lesson is going to be able to use that deductive reasoning to form a logical argument. And this is laying the foundation for what become geometric proofs. So deductive reasoning, facts, definitions, accepted properties, and the laws of logic to form the argument. And again, inductive reasoning uses specific examples and patterns to form a conjecture, conclusion, or statement. So the laws of logic, these are a couple new terms for you. The first law is the law of detachment. So the law of detachment says if the hypothesis of a true conditional statement is true, then the conclusion is also true. Or what you could think of is if the hypothesis becomes true, then the conclusion also happens. And we'll look at a few examples down below. Then we also have our second law of logic, which is the law of syllogism. And the law of syllogism says if part A and B are true, then C is true. And we're looking at A, B, and C here for parts A, B, and C. So if parts A and B are both true, then C is also true. So A says, if the hypothesis P, then conclusion Q. So if that becomes true, and if the hypothesis Q, then conclusion R becomes true, we can then state if hypothesis P, then conclusion R. So in other words, if P, then Q, if Q, then R, so then we can get rid of the repeated Q and say if P, then R. And we'll look at a couple examples of that as well. So example 1 is asking us to use the law of detachment to make a valid conclusion in these given situations. So situation A, if you get a hit, then your baseball team will win. And then what ends up happening is you hit a home run. So here is our conditional statement. If you get a hit, then your baseball team will win. What we know is you hit a home run. So our hypothesis became true. So then we know by the law of detachment, our conclusion is also true. So you hit a home run, therefore your team wins the game. In B, anytime Kendra runs in a cross-country race, if she runs a strong race, then she wins. In the cross-country race last Saturday, Kendra ran her best race. So Kendra ended up running her best race. So that would be considered a strong race, and if she runs a strong race, then she wins. So the hypothesis of if she runs a strong race came true. So then the conclusion, Kendra won the race, is also true. And then our last example for the law of detachment, it's part C, gives us the hypothesis: if you double a negative number, and then the conclusion, then the result is a smaller number. And then what ends up happening is you calculate 2 times x, where x is less than 0, which would mean x is a negative number. So if you're doubling a negative number, meaning if you're multiplying it by 2, then the result is a smaller number. So in this case, they calculated 2 times x, where x was less than 0. So what that tells us is the conclusion is true, that we get a smaller number. So the way we could represent that is 2x ends up being less than x, because any number doubled, so any negative number doubled, ends up giving us a smaller number than the original. And that would be 2 multiplied by x is less than x. So we would represent that algebraically with an inequality. Example 2 then, parts A and B, are going through the law of syllogism. And in this case, the law of syllogism, again, requires there to be 3 parts. If P, then Q, if Q, then R, and then we can state if P, then R. So if we are looking at our statement A here, it says, if Moose, guess someone's named Moose, or just a moose named Moose, if Moose is hungry when he goes to the pizza shop, so we have our first hypothesis, we could call this P, then he'll finish a whole pizza. So our first conclusion, we could call that Q. Then it says, if Moose eats a whole pizza, so we're repeating the conclusion, but now as our hypothesis. So if Q, if Moose eats a whole pizza, then he goes through a pitcher of soda. So that would be then R. So then if these came true by the law of syllogism, we would state, if Moose is hungry when he goes to the pizza shop, we're taking our original if P and our final conclusion of R, then he goes through a pitcher of soda. And then in B, our original hypothesis, if a triangle has 2 angles of 60 degrees, we get our original conclusion, then the triangle is equiangular. Then we're using that original conclusion as our next hypothesis. If a triangle is equiangular, then it is also equilateral. So in this case, we can drop that repeated part in the middle, then the triangle is equiangular, and if a triangle is equiangular, we get rid of that repeated statement, and then we can state, if a triangle has 2 angles of 60 degrees, then it is also equilateral. So if P, then Q, if Q, then R, so our final statement would take that form of if P, then R. So matching the law of syllogism. Then we get down to example 3, where we're deciding whether the conclusion reached from the 2 different statements demonstrates the law of detachment, the law of syllogism, or neither. So statements in part A. If Cedric plays in a big game, then he gets nervous. If Cedric gets nervous, then he performs well. So right away, what I notice reading that is, then he gets nervous, and if he gets nervous. So they're repeating a statement there. So that flags to me, it could be the law of syllogism. In order for that to happen, they'd have to match up the first statement and the very last conclusion. So what conclusion did they come to? They said, if Cedric plays in a big game, then he performs well. If Cedric plays in a big game, then he performs well. So that would be the demonstration of the law of syllogism. Dropping that repeated part, then he gets nervous, and if he gets nervous. Part B. If Leanne spends more than $30 on her car, then she'll have to wait until next week to buy Michael's birthday gift. What ended up happening was Leanne spent $40 on her car. What that tells us, then, the conclusion that they came to, was Leanne will have to wait until next week to buy Michael's gift. So in this case, we had one hypothesis and a conclusion. If she spent more than $30 on her car, she'll have to wait till next week to buy the gift. The hypothesis became true. She spent $40 on her car. Therefore, the conclusion is true that she'll have to wait till next week to buy the gift. Law of detachment. And then C, if Levon gets money, she gives half of it to Sid. If Sid gets money, he gives half of it to Levon. The conclusion, Levon and Sid share their money equally. That doesn't demonstrate either the law of detachment or the law of syllogism, so we would answer neither. And then looking at example 4, deciding if we're using inductive or deductive reasoning. So in A, it says, while shopping for a product, you notice that brand A is more expensive than brand B. You conclude that brand A is of higher quality than brand B. So you're thinking the more expensive product is the higher quality. So that's using patterns or specific examples. In this case, it would be a specific case, and you're putting together a pattern or conclusion in your head. So that would be inductive reasoning. So one specific example or patterns, inductive reasoning. In B, it says because the brand A product cost $1.50 more and the brand B product cost $1, you conclude that the brand A product is 50% more expensive. So $1.50 compared to $1, mathematically, that is 50% more expensive. So in that case, that would be deductive reasoning because you're using facts and data. And then final example for this lesson, example 5, we have parts A and B. Part A asks you use inductive reasoning to make a conjecture about how the area of one square compares to the area of another square with sides that are twice as long. So we had a picture here to help us out. So in this case, let's consider this lower left gray square our original square. Then the big square would have sides twice as long. So inductive reasoning would be looking at this specific image and making our conclusion. So the square of the area of the square with sides twice as long will be, and we can say specifically, 4 times larger. And the way we know that it will be 4 times larger is by looking at this image. If this is our original square, the larger square with sides twice as long can fit 4 of the originals inside. Then we want to use deductive reasoning to prove this conjecture. So in this case, use deductive reasoning to prove the conjecture, and we were given side length of x and a side length of 2x. and then the area of a square formula. So x squared is the area of the square where the side length is x. So if this was our original square with side of x, to figure out the area, it's simply x squared. Then 2x squared, so 2x to the second power, would be the area for the bigger square, because this side here would be 2x, and this side here would also be 2x. So 2x times 2x gives us 4x squared. That would be the area of the square where the side length was 2x. So then comparing these two areas, x squared and 4x squared, we show that the area is 4 times larger. So the deductive reasoning proof is actually using the mathematics, doing a calculation and a comparison, where the inductive reasoning, saying it's 4 times larger, we could just look at the pattern or the image, and our one specific example can help us draw that conclusion. So those are your main differences between inductive and deductive reasoning. But as we go back to the main idea of this lesson, it goes back to deductive reasoning, which uses facts, definitions, properties, and the laws of logic. And then our laws of logic are the law of detachment and the law of syllogism.